name of Owens and a guy by the name of Kern. And so I've been in state for a while. I grew up on a ranch. I was fifth generation there. I went to Humboldt State College and got a bachelor's degree in rangeland management. I did graduate work in wildland hydrology, and I also have a degree minor in geology. And after college, I got a job with BLM, originally working out of the Bakersfield office, but working this area. And in 1974, in 1976, they moved the office here to Ridgecrest. And so I've been here in Ridgecrest since 1976, living here. And so I've had a chance to kind of look at this area for quite a bit. I've, in my career here with BLM, I worked as a ranger, as a range conservationist, and then most of my career I've been a natural resources specialist. And I had responsibilities for botany, soil, water resources, and air resources. I also did wildland fire as a resource advisor and other things that came up, it seemed like. I retired in 2013, and I developed a bunch of new processes with BLM, and result is I got the Distinguished Service Award from the Department of Interior, which is the highest award I could get, and I was really proud of that because my people I worked with gave that to me. Since I retired, I've been doing volunteer work both for BLM and here at the museum, where I take environmental education into the classroom a lot, or I used to until COVID hit. So this is probably kind of an oddball looking scene of Joshua trees in a snow-covered landscape, but this isn't unusual in terms of it's happened many times in the past. Large continental ice sheets have covered the northern hemisphere and retreated many times. And it's interesting that most of the ice ages have affected the northern hemisphere more than the southern hemisphere. When we got these large ice sheets, we call them a glacial period or an ice age, which is a common name we use. There's also times without large ice sheets, and we call them interglacial periods. And they seem to be caused by variations of Earth orbit. And it seems to vary over time. And the amount of radiation that reaches Earth changes. So we get interglacial periods when there's more intense summer radiation, and go the other way when it drops off. Glacial periods are generally colder and dustier, and generally drier, which seems kind of strange, but it turns out that when you pile all the water in the world on as ice on top of the continents, the oceans go down and there isn't much left for anything else. And so a tundra type of a condition develops, and steppe type of conditions develop away from the glacier. Here in this valley, we were close enough to the glaciers, and there was water coming off of them that this area stayed a little bit more moist, and we see vegetation from that time that reflects that. Many of you have seen geologic timescales, and this is the last piece of it, but down here at the bottom we see the Precambrian. The Precambrian was the first 4 billion years, and this part here represents the last 500 million years. And what we're interested in looking at really is this Quaternary and the Pleistocene and the Holocene. The Pleistocene period was basically a period of ice ages. So for the last about million years, we've had a series of ice ages. And this is a chronology of those. down here at the bottom, we have a Nebraskan, and there was a series of interglacial names that I've never heard before, except that I believe these are Indian tribe names. But we have the earliest is Nebraska, the Kansas, Illinois, and the Wisconsin is the one that basically affects this area the most. And trying to figure out how other ice ages might affect areas is difficult because each one wipes out all the evidence of the previous one. So if we take a look at this Tioga period, or down here, right here, this is the most recent ice age that we had that affected this area. But you can see we had one called the Sherwin, which was almost 1 million years ago, and the Tahoe one. And each of these seemed to affect different areas. The Tioga is one that filled most of Yosemite Valley full of ice. And so there were some very large ice sheets during that time. Since the end of the Wisconsin period, though, we've been in an interglacial period, and this has been called the Holocene epoch. And I was going to put that in the title, but I thought people would think that looked too complicated, so I decided to say just since the last ice age. If we look at the world about 18,000 years ago, it looked like this, and it's kind of hard to figure out. This is North America here. This is almost like looking down from the North Pole, and Siberia here. And it's interesting, the ice ages basically started not with ice forming at the North Pole and moving south, but forming in the Canada and the northern tier of Europe on the continents, and moved out from there. There was ocean ice associated with it here, but the main ice sheets were here on the continents. And sometimes that was pretty dramatic. In where New York City is now, there was probably 800 feet of ice. And so if you're worried about the ice age, you probably ought to worried about global warming, you probably ought to worry more about the ice age. We can deal with the water coming up a couple of feet, but how about 800 feet of ice? And you can see here in our current time, those continental ice sheets are gone pretty much except for Greenland here. It's interesting looking at temperatures and some of the other factors. This line here represents temperatures, and across the bottom we have years. Here's 50,000 years ago and so on. Here's our last ice age was in here. And you notice that, look at the temperatures. They suddenly came up. It was a pretty dramatic increase. When you look down here at carbon dioxide level, it also shot up at the same time. And it turns out that when the oceans are cold, they absorb a lot of carbon dioxide. And so that's the reason some of our ice cores that we have are very low in carbon dioxide. And some people have been comparing that to current carbon dioxide levels and say, we're dramatically increased. Well, we have, but it's partly because it was tied up in the oceans. So we had a dramatic increase. And what happened is, if you ever leave a can of soda pop out and it gets warm, open, you notice that all the fizz goes out of it. Well, that's carbon dioxide, and the same thing happens with the oceans. As they warm up, they dump carbon dioxide. So this was basically a greenhouse gas here that caused this great increase in temperature. And so the ice age ended very quickly. And some of these drops going into these ice ages, like here, some of these look like we went from a temperate climate to an ice age in 35 years. So it's interesting looking at these, and we don't know the total mechanism. We know that it has to do with heating and so on. So this is what it kind of looked like in this valley at that time. Right, this is Mono Lake right now, but it's comparable to what this valley looked like coming out of the last ice age. And this is Mono Lake here, but we had a lake in the valley here also. And this was the vegetation that was around here. We had the pinyon pines, the big sagebrush, And that was common in this valley, down low, and then a lake. This is where the Owens River came down through, and it was the supply of water, a tremendous amount of water. But over time, that water diminished because the glaciers went away. It shows that they warmed up very quickly. And so they went away and they dried up. And we had these lakes down the valleys that dried up like this. Just for your information, this is Deep Springs Valley. This is Death Valley, and we see the deposits that were left after the water dried up. Over here in Searles Valley, east of us, the water was over 700 feet deep. And these were left over in Searles Valley, the Trona Pinnacles. And so the question is, what's this have to do with vegetation, which is what I'm going to talk about? There's ecologists like to dream up names and so on, but they also like to classify things. And Charlet and Billings here both have a classification for this area that kind of works. And if you look at this, this is actually an elevation drop sequence. So we have the alpine at the highest elevations and the salt brush and even the lake beds at the lowest elevations here, with these other vegetation types filling in the block after that. Charlet also developed this thing. If you look at these as mountains, you can see at full glacial here, we had lakes and salt brush around the lakes, black brush, which now occurs up quite high, what we call a pygmy conifer here, the montane and subalpine and so on. Some of these didn't occur in this valley, but they were pretty close. The present day, and you see these lines that they go down, that's because this is the north exposure and the south exposure, and they're lower on the north side. The current day, they show an absolute desert in their classification with salt brush and so on up to alpine. And with global warming, this is one of the projected looks of it, with the alpine and the subalpine being squeezed right up to the top. So where are we talking about? Here's California, Southern California. This is Monterey Bay here, Santa Barbara, Los Angeles here, Lancaster, Mojave, Barstow, and here's Ridgecrest right here. This is the Searles Valley here, or in Wells Valley, Searles Valley over here. So when we blow that up a little bit, here's Searles Valley. It's about 700 feet lower than the Indian Wells Valley, but we were all the same lake. No, it's this lake went from over here all the way through all of this. And it was actually one of the largest lakes. And then around it, we had a series of other vegetations, probably the pinyon pine and so on as that dropped down. I'm going to look at a little spot right here called Robber's Roost. There's an interesting creature out there called a pack rat. And they are random samplers of everything that's around them, and they stack them in chronologic order. And so we're able to go back and look at their piles that they developed historically and date them and look at the plants that are there and figure out what might have been in that area at that time. So we get a plant list that looks like this. And on this list, if you see a plus, that means that the plant was present at that time. A 2 means it was not present. And so we go down this list of things, and these are all scientific names. So I'll give you some names here. This is Amsynchia, that's fiddleneck, Artemisia tridentata, that's big sagebrush. And we saw that in that picture with the pinyon pine. Ceanothus, the golden bushes, California buckwheat, the junipers, desert alyssum, lupin, the beaver tail cactus, and the cholla, penstemon, the pinyon pine, bitter brush, some oaks, and Joshua trees. Surprisingly enough, Joshua trees were in this region with snow. So that first picture I had with Joshua trees and snow existed during some of the Ice Age. If you take a look at this one here, I've tagged the ones that are still at that location. And you notice not many of them are at that location anymore. They've gone someplace. And it's because it's warmed up and dried up. Some of these are not even in the basin anymore. And some of these, you can see it was present here, and gone here. And some of them only showed up later here. And other ones disappeared as it dried up. So here's what it looks like at Robbers Roost right now. And of all those plants that it said was at Robbers Roost 13,000 years ago, here's the cholla cactus. And the Joshua trees up here. Some of that other stuff is these pieces up here or up farther north. All this stuff is new, including this stuff here. You know what this is? That's creosote bush. That's a good one. Yeah, and you go back and look here, there's no creosote bush, is there? Well, creosote bush is one of the newcomers, even though it's probably the most widespread and successful of our desert plants now. It only arrived here about 7,000 years ago. It apparently arrived in Barstow about 8,000 years ago and came in from the southeast someplace. But the creosote bush that's in New Mexico and Texas is actually a different genotype. Ours more closely resembles the one that comes from Argentina, which maybe means that we had birds flying back and forth that brought seed or something, kind of an unknown. Here's beaver tail. And that's a very prolific beaver tail. And the Joshua tree. This is probably one of the bigger Joshua trees I've ever seen. This one is almost 2 feet across. It's located in the coastal wilderness area at a place called Joshua Flat. And it's sheltered from wind there and has pretty good moisture, so it's been able to grow and stay there. And then there's some Joshua trees that look like this. Well, it turns out Joshua trees branch when they flower. So these has never flowered. Those are about 40 feet high. And they've never flowered, so these are sterile. These are up on the Naval Weapons Center, these particular ones, but we find them other places too. Then the lupin, which we found there in the mix at Robbers Roost, is now way up the canyon. And this is a Joshua tree woodland. It looks like around here, except this is White Mountain. This is the White Mountain Range here. And this is Fish Lake Valley. So they've moved that far north. This area was probably fairly cold at that time. And just over this ridge right here is Deep Springs Valley. And there's one creosote bush there. So we think that's probably pretty close to the extent of the range. There is creosote bush over in this area here. And this is what's replaced everything. All these annuals, the creosote bush, the burro bush, a bunch of other pieces in here, the apricot mallow, and very rich group of annuals, because annuals are very well adapted to the dry conditions. They can survive as seed in years when there's no moisture like this year, and come back up even 50 years later when it finally rains someplace, and there's evidence of it doing that. That was in Short Canyon, and flowers like this, and some of them pretty showy. Apricot mallow, golden bush. One of the golden bush like this was found around Robbers Roost. Not that species, the Indian paintbrush. And so what happened to the vegetation that was out there at Robbers Roost? Well, it's up here, about 3,000 plus feet up from Robbers Roost. Robbers Roost is just above 3,000 feet elevation, and this is about 7,000 right here where I'm standing. And this is the Indian Wells Valley. For those of you who know the area, this is Owens Ridge. And this is Indian Wells Canyon. And so Ridgecrest is out in there. And this is what, again, what it looks like. Here's the pinyon pine, and here's the big sagebrush, like we saw in that other picture, but was down there at Robber's Roost 13,000 years ago. And we find these big pines and so on now growing up in the high mountains there. And then there's this plant here called Nolina. And we can use that kind of an example of what's happened to some of the plants. This is at about 7,000 feet, and it occurs right here and in Short Canyon here. And it's interesting that this is a female plant, this is a male plant. That inflorescence is about 10 feet from there to there. And they don't bloom every year. They bloom kind of when they feel like it, I guess. I don't know, but they all bloom at once, which is fortunate, because if they didn't, you'd never get any seed off of them. So if we look at the map here, there's the map. Where we were looking is the Nolina that we're looking at occurs in this area here. It also occurs over here. But you notice all this piece in between? Well, what we think happened is during the Ice Age, or when it was colder, it was actually a continuous population across there. But now it's stuck in the mountains here and in the mountains here. Then there's this is Owens Peak. I'm on Mount Jenkins here taking this picture standing on the Pacific Crest Trail. And again, it's about 7,000 feet around the trail there. Down at my feet, there's this little plant. It's called Owens Peak Lomatium. And go back and look here. The total range of the species from where I'm standing to there. All the known plants are there. This is another picture of it. You know, it's almost spiky looking things. The lomatiums are in the carrot family. Then you turn and look west from there, and you notice these trees up here. This is the top of Mount Jenkins up here. We have white fir, Jeffrey pine, sugar pine, mountain maple, and a bunch of stuff like that growing in here. It's a little pocket, and it's one of the southernmost stands of sugar pine in the Sierras. And it's a pocket that if you look up there in the wintertime after a snowstorm, you'll see a white stripe here of snow that holds in there. And so there's enough moisture here to support those trees up in there. Then there's this little piece here. See this little habitat here where it seems to get kind of barren? For those who remember, this is Shelley Ellis. And she's looking at something there that looks like this. This is an astragalus milkfish. It's called Walker Pass milkfish. I've been to that population about 3 times. The first time I was there, I counted 9 plants. The last time I was there, I counted 29. But when you think that there's one other population of it south of Walker Pass. When that's all there is 29 plants in that area. That's pretty rare. And it's growing on this site that nothing else seems to like to grow. If you look back here, that's a pinyon pine there. It's pretty stunted. But some of these rare plants that we have grow there because they don't have competition. There's another one that's up there called a 9 Mile Canyon Phacelia. And all of these plants seem to be growing at that high elevation. And the populations are starting to get separated by elevational breaks. So we have each of the mountains that sticks up there becomes what we call an island in the sky. And you have a chance for a species to get trapped up on that island and become a separate species from any of the other ones around it. Even of the same genus, they would be different. These are both Phacelias. Obviously a little different. Most of you recognize as Charlotte's Phacelia. That other one was 9 Mile Canyon Phacelia. There's another one that's up there. It's a member of the mint family, very smelly, Dudleya, that's up in there. All of these are up in that pocket of leftover habitat on these islands. This is a bitterroot. It's kind of unusual to find it in this country. And this is where it grows. That looked like a really lush site, but it's there. There's one there and there's some here. And there's another piece there. And many of these rare plants you find growing on places like this. Most of you think of cactus and deserts, and we have cactus here. We saw 2 of them that were there at the Robbers Roost site, and we have a few others, but they're pretty hardy. Most of our cactus are able to stand cold. Beaver tail I've seen clear up almost 8,000 feet. And it seems to be able to handle the cold pretty well. This is cotton top cactus. This is a cholla in bloom. You see the flower. It's kind of a strange one. It's green. Hedgehogs and in flower. Some beaver tail and flower. This is fishhook cactus. It's kind of a strange one. It occurs in little pockets and not very many plants anyplace. Like this one here and one there. I've seen it all the way from Fish Lake Valley down to Victorville area, but never very many anyplace. It's unusual in that these dark spines here have a hook on them. And then there's things like this that are unusual. It only occurs in about 3 canyons or 4 canyons in the Panamints. This is Panamint daisy, and you see from my hand there that it's a fairly large plant. Oh, and some of the primroses are rare. And then we have what we call the riparian habitats that have their own thing. So we have grape growing in here and willows and a whole series of different pieces. And these also tend to be little pockets of habitat where some of these other species are hiding that wouldn't survive otherwise that were here before. Yes, this stuff occurs too. So what does this mean for continued warming? What happens? We can learn something from looking at what plants have already done. And we see that they move up the mountain slopes to higher elevation. So they can survive. And because the change is slow enough, they can do that. Some of them may get caught in these islands in the sky, and we're seeing that happen on some of them, is that they're now on this mountaintop or that mountaintop. Something interesting is that most of the mountain chains in North America run north and south, which means that plants can move north as it gets warmer and south as it gets colder. And so they can survive because of that. And there's some species that may die out. They'll get caught someplace and never make it. And there's some that are never very large numbers, like that astragalus, the milkfish, where there's 29 plants. Wouldn't take much to wipe out the entire population. And other plants may move in and replace the ones that are lost, as we saw here in the desert with all these annuals and everything else that arrived here after the Ice Age. And who knows, we may even get an ice age come in here and cover everything with ice. And global warming might be what keeps the Ice Age out, who knows. So this is one of the summer thunderstorms in the area. I don't know if any of you remember the big thunderstorm that wiped out Red Rock Canyon about 20 years ago. This is it right here. It dropped 12 inches of rain in about an hour. So this is a never-ending story. Instead of ending it on a sunset, that's the sunrise at New Year's morning. So anyway, that's the basic part of my presentation. Certainly open for comments, questions, what have you. Yeah.
How many pack rat nests have been studied? You mentioned the one.
There was a series of them they found.
From where to where?
They occur all over the place. That particular study centered around Robber's Roost, yeah. And it had bearing because here we are right in the middle of that. For those of you online, the question is about the pack rat middens and how many of them are there. There's actually quite a few of them. They spread over most of the desert and even outside the desert. And they've been used for studies all over the place. There's also another source of information, which is pollen that's tied up in lake bed sediments. And we can look at the sediment layer, and pollen is very persistent and identifiable. And so we have actually several ways of looking at what the paleo vegetation looked like. Any other questions? Elaine, do you have any?
No, but someone just raised their hand and I didn't catch the name. So if you want, if you raise your hand again, I can maybe see if I can let you speak. See if we can hear you.
I'd repeated the question. Did you catch that?
No, I didn't. That's
okay. I'll go ahead and repeat it. What he was asking about is the pack rat middens and how many of them do we have, and how many were used in the study. I don't know how many, but there are quite a few, and my understanding is they used a number of them, and they were consistent in what they were seeing. There were pack rat middens all over the desert, and as you know, pack rats are fairly common. Most of you have been out in the desert around rock areas. You see those piles of stuff that the pack rats have put there. Beer cans and everything else are in that pile. And fortunately, they put that stuff in chronologic order, and we can carbon date it and figure out what was there in the past. The particular study we looked at there was from Robber's Roost that was done a number of years ago. But there are other such studies around. I used that one because it was this valley and we could apply it to what we see here.
What conclusions are being drawn or proposed from the amount of carbon dioxide in the atmosphere that is being considered to be coming from being released from the oceans? The excess or rate of carbon dioxide accumulation in the atmosphere, you said a lot of it had been trapped for years in the ocean. And so it's gradually being released as the temperatures change.
Yeah, so it's temperature dependent on how much. The question is about carbon dioxide in the ocean and the variation and so on. It's temperature dependent on how much the oceans can absorb. And right now, the oceans are actually a large sink for carbon dioxide. And so it tends to buffer the numbers. So when we get excess buildup, it may end up in the ocean. And it may end up causing blooms of algae and so on, because algae uses carbon dioxide in its photosynthetic process. But in the past, from that chart I showed you, you could see that as the temperature dropped, the carbon dioxide level in the atmosphere dropped also, down to some very low levels. Um, and some of the ice core data shows those numbers. And then from what we can tell is that there was a dramatic jump in those numbers, and it had to do with the oceans getting warmer. And it's just like putting a soda pop out in the sun with a cap off of it. It very quickly, as it warms up, it goes flat, as we call it, because it gives off all of its carbon dioxide. And the oceans work that way also. They don't warm up as much, but they can get fairly warm sometimes. My son was on a ship in the Persian Gulf, and he said the water temperature was 110 degrees outside the ship. So they can get warm, or they can be up in the Arctic Ocean and just at 32 degrees. Any other questions? Did you get that one, Elaine?
I did, and you have a question. I'm going to read it to you, or let me hit answer live, and then you can probably read it out loud. Okay, I'll read it to you. It says, any evidence in the northern Mojave of an especially warm period 7,000 to 9,000 years ago in North America. Some refer to this period as a xerithermic or Holocene thermal maximum, about 5 degrees Fahrenheit warmer than the present. It says, it's for your information, my microphone doesn't work. Would you like to, can you see that question? Can you go down to the Q&A on the bottom and read that
Yeah,
question out loud?
could you just read it again for me?
Okay. Any evidence in the northern Mojave of an especially warm period 7,000 to 9,000 years ago in North America? Some refer to this period as a xerithermic or Holocene thermal maximum, about 5 degrees Fahrenheit warmer than present.
Well, there's actually been a series of warmings. There's evidence that there's about 1,000-year cycle. We know that around 1,000 years ago, that there was a warming period that affected most of the northern hemisphere anyway, where in Europe, their agricultural practices changed in northern Europe to where they started growing grapes for their alcohol instead of grains. That's when the Vikings came across the North Atlantic. It's when the Anasazi disappeared from their habitat. They went from farming to hunter-gatherers. And Mono Lake, there's evidence that if you go down about 90 feet, there's evidence of a lodgepole pine forest underwater there that dates from that period of time, which would indicate that Mono Lake almost went dry at that time. And there's evidence farther back at the time of the Roman Empire, the empire that civilization that built the pyramids, it suddenly died out, and they found out that the Nile River dried up. And it's again on that cycle. And so I don't know of a specific one 9,000 years ago, but we know that within 1,000 years, we were back to basically a temperate climate in the desert area after the end of the Tioga period. And we see it from that chart that we looked at.
Did that answer your question? If not, then you can.
I don't
ask
know of
another
any 9,000 years ago that reached a maximum. We know there's quite a bit of evidence of the one about 1,000 years ago, and there's reference of different kinds on some of the earlier ones. On the one, they discovered the Nile River actually dried up, and it has it historically is flooded every year, and that's floods their farmland and is important for their farming and agriculture. And when it does that flooding, there is a lake that's off the side of the river that fills with water, flood water. And then as the river goes back down, it gets cut off again. And taking cores from there, they discovered that there was a missing set of data, that it didn't flood a whole bunch of years from that period of time. And they originally started looking for answers because they were trying to figure out what happened to that civilization, that it apparently died off very quickly, and it wasn't a military type of a thing. People were fighting each other and dying, mass graves. And you can imagine their economy that was based on the Nile River suddenly disappearing, the food supply disappeared. And there is those type of studies. There wasn't very many people around 9,000 years ago to write about it. So I'm not sure on that. There probably is some way to look at it, but I don't know specifically of that one.
Okay, well, thank you, Glenn, very much for your presentation. We appreciate it. That was very nice. And at this point, we're going to end the Zoom session and wish you all a good evening. Thank you for attending.
Yeah, thank you. Have a good day.
Good day.